In the last section, we talked about how to convert from a polar coordinate to a rectangular coordinate, and now we're going to go the other way around. Now, this way is a little bit trickier, namely because every answer you get actually has lots of different possible answers, so we're going to have to consider the other versions of them as well because of the coterminal concept. The fact that 0 and 360 and 720 and 1080, they're all the same angle, so you can keep expressing the same location with a coordinate by just adding 360 around your unit circle. So here are the rules when you are going from an x and a y value, which we call a rectangular coordinate, into an r and a theta value, which is what we call a polar coordinate. So just as a refresher, this measures left to right and up or down motion. And here we're talking about a distance along a diagonal and what angle that diagonal is pointed at. So that's the two different ways to describe a location. The formulas we will use to convert are that r squared equals x squared plus y squared, in which case you'll just take the two numbers from your ordered pair, you'll plug them in, square them, and add it together. And for the theta value, you're going to hit tangent inverse of y over x. Now, just like we had in the last unit, you do have to consider which quadrant your coordinate is actually located in, because the answer you get, it could be that one, or it could be that plus 1 pi, or minus 1 pi. The plus n pi here is just saying that there are actually an infinite number of ways of expressing that tangent inverse value. And basically, every time you add or subtract pi from it, you'll just get another value that has the same angle. So you do have to think about the fact whether your answer is actually supposed to be in quadrant 2, then you might not want to use an angle that you get out of quadrant 4. You would want to either add or subtract 180 degrees or 1 pi radian to it to get the same thing. So each rectangular point has many equivalent polar coordinates because they can just be expressed in an infinite number of ways. And some of the questions will make you do things like state all of the different versions between 0 and 4 pi or negative pi and pi. So you'll have to think about the different coordinates you can get by either adding or subtracting pi from your answer. So let's jump into looking at some of the examples we have. Now, one thing I don't like from the way they listed out the formulas here was that instead of them writing that r squared equals x squared plus y squared, they've gone ahead and taken the square root of both sides of the equation. But when you do that, that leaves off the fact that you actually get positive and negative answers. So I would have liked for them to have written the plus or minus out front when they were setting this up. Anyways, the first thing we're going to work on here is finding the r value. So like I said, they're doing the square root of x squared plus y squared. They're just plugging in the x and the y value that we have from our coordinate, squaring them, adding them up, and then taking the square root of that. So in this case, since that number is 0, you're really just doing negative 11 squared, and the square root is back to 11. Next, you need to find the theta value. So if tangent of theta equals y over x, then we have to do tangent inverse of y over x to find the value. Now the problem with this specific example is that our y value is negative 11 and our x value is 0. So if you write the fraction y over x, you're actually getting an undefined value. Now if you look at your unit circle, the only times that tangent is undefined are at 90 degrees and then again down here at 270 degrees. So we know that one of these values is going to be the one for our answer. And then if you remember, we pointed out that our coordinate was located down because it was 0, negative 11 for the coordinate. So that means in this case, we want to use the 270 degree version, not the 90 degree one. The negative degree one could be used if you put a negative r value in front of it, because then the negative r value flips it around. But for our example right now, we're going to stick with the 270 degrees. So when they set up this tangent inverse and they were looking at the two options, is it 90 degrees or 270 degrees? Since our coordinate in this very specific case is going down, it has to be the 270 degree one because that's the one that points down. So now we know our theta value and we know our r value. And then they also asked us to convert the degree measurement into radians. They want us to express both. So the degree measurement we picked was 270. For the radian measurement, you could just look at your unit circle and see that 270 degrees is the same as 3 pi over 2. You might already have some of those memorized. Or they actually show the conversion that we did when we first learned radians and degrees, that you can multiply by 1 pi radian over 180 degrees, which makes the degree symbols cancel out. So they got 3 pi over 2. So altogether, the two different ways of writing the polar coordinate, the r value is 11 with 270 degrees for degree mode. For radian mode, the r value is 11 and the theta value is 3 pi over 2. So that's one example of converting from a rectangular coordinate into a polar coordinate. Now I'm going to jump ahead in the assignment to one of the more complicated questions where you have to list all of the possible answers in various ranges. But we're doing the same thing. We're still finding the rectangular coordinates. So that part of the process will be the same. It's just now we're going to consider all the other ways of writing those same coordinates over and over again with different angle values. So they ask us to use an algebraic method, approximate the solutions, and then we're going to be multi-selecting which ones match our answers. So let's look at the example we have here. So starting off, we're going to focus on the interval from 0 to 2 pi, which is nice because that's what our unit circle shows. And then we can just do conversions from there. Now, the coordinate of our example is going right 25 and then down 25. So we know that our coordinate is going to be located in the fourth quadrant, and they went ahead and plotted that just for reference. Now, we're not really going to use this graph for much else other than recognizing that it is in fact in quadrant 4, which will affect which angle and R value pairings we choose later on. So make sure you do think about which quadrant your coordinate is in. Okay, the first thing they did was they went ahead and they found the r squared value by using r squared equals x squared plus y squared. Now, like I said, I prefer when they write it this way because that shows them getting 1,250, and then when they take the square root of both sides, you get a plus or minus answer. They didn't show that on the last example, which I wasn't really that happy with. So that was a different textbook's problem, and I guess they didn't really emphasize the positive and negative answers in it. So by taking the square root of both sides, don't forget you get a plus or minus. If you break down this radical 1,250, we have two answers at this point. Now the next thing we need to do is find the theta value. So for theta, we're going to do tangent inverse of y over x. Now they broke it down a little bit differently. They just went ahead and found what tangent of y over x equals, and they simplified that. And then when they saw that tangent of theta equals -1, they looked at their unit circle and found where do they have tangent values equal to -1. Well, that should happen at 135 degrees, and opposite it, if you look 180 degrees away, it'll flip around and you'll see it again at 315 degrees. So they found what the tangent value was, then they did the inverse, and then, like I said, this plus n pi here, this is just saying it actually happens an infinite number of times. If we look back at our unit circle, not only does it happen at 3 pi over 4 and 7 pi over 4, if you add another pi to it, it happens at 11 pi over 4, and then 15 pi over 4, 19 pi over 4, 23 pi over 4. If you keep adding 1 pi, and remember you need a common denominator for that, that's why it's actually adding 4 pi over 4, you'll get an infinite number of ways of expressing those same two angles. We're basically just finding the coterminal ones of these two positions, the 7 pi over 4 and the 3 pi over 4. So that's what they're indicating when they say plus n pi. Now, for the values between 0 and 2 pi, which is what we're going to focus on for part A, the two most prominent ones are going to be the 3 pi over 4 and the 7 pi over 4 that we already pointed out. So these are our two theta values, which are paired with our two r values that we found earlier, positive 25 square root of 2 and negative 25 square root of 2. Now to pick which ones get paired together out of the two r values and the two theta values, make sure that you're making the coordinates line up in the fourth quadrant. So the 3 pi over 4 angle, 3 pi over 4 is actually up here in the second quadrant. So what you would need to do to make that coordinate represent something in the fourth quadrant is pair it with a negative r value, because negative r values flip around the origin. So they took the 3 pi over 4 angle and they gave that the negative r value of negative 25 square root of 2. And then they took the angle that was already in the fourth quadrant, 7 pi over 4, and they paired it with a positive r value that we found. So these are the two r values and the two theta values, but you have to be careful about how you pair them up to make sure that you end up with a coordinate in the right location. So now we have our coordinates for the 0 to 2 pi interval. This is all of them. There aren't any other angles that are going to end up equaling the -1 value we were looking for in tangent inverse. So for part A, you would go through the various answer choices and you would mark all the ones that matched those two and only those two answers. Now part B is going to be the exact same coordinates, so we don't have to redo any of that work. We just have to reconsider which angle values we're interested in, because now we're not doing the angles from 0 to 2 pi, we're doing the angles from negative pi to positive pi. So negative pi angles, if you hopefully remember, those are ones on the unit circle where you just rotated clockwise instead. So pi over 6 means to go counterclockwise pi over 6. Negative pi over 6 means to go clockwise, pi over 6. So looking back at the answers we had from part A, we had a 3 pi over 4 angle and a 7 pi over 4 angle. Now 3 pi over 4 is in that interval negative pi to pi because it's just less than 1 pi. But this one is too big, so we're not going to be able to use this coordinate, so we would cross it off from our possible answer choices from part B. However, if we remember that we can just keep adding or subtracting pi and getting similar answers, then we should find that there's another way to write 7 pi over 4. If you subtract pi from this one, you would have negative pi over 4. And negative pi over 4 will fall in that interval of negative pi to pi. So by subtracting a pi value, we just have another way to write that 7 pi over 4 angle. 7 pi over 4 and negative pi over 4 are the same angle. So we're basically just going to replace the 7 pi over 4 value with negative pi over 4 instead. And then we still have the other coordinate that already fell in the right interval. So negative 25 square root of 2, 3 pi over 4, and 25 square root of 2, negative pi over 4. So now we still have two coordinates that match the given specified domain on this one. And then moving on to part C, we're doing the exact same thing. We still have our two coordinates, but this time they want us to list all the angles between 0 and 4 pi. So on this one, we couldn't use the negative pi over 4 angle because that theta value does not land between 0 and 4 pi, but we could use both of the ones we had in part A, the 3 pi over 4 and the 7 pi over 4. So now we have 3 pi over 4, 7 pi over 4, and then we can keep adding pi to those answers. So if you add another pi to that, then you would have 11 pi over 4. If you add another pi to that, then you would have 15 pi over 4. So what they're showing you here is just that starting from the first angle, negative pi over 4, you can add pi, and you get 3 pi over 4. Add pi again, 7 pi over 4. Add pi again, 11 pi over 4. So they're just showing that there are an infinite number of ways of writing these angles, and then we care about the ones that actually fall in the interval from 0 to 4 pi. So we're ignoring the negative pi over 4 one, and we're using the 3, the 7, the 11, and the 15. If you do it again, that would take you to 19 pi over 4, and 19 over 4 is bigger than 4 pi, so that one ends up being too big. So that's why it's just these four angle values that we're going to be using. And then again, we have to make sure that we pair them with the right r values to make sure that they are landing in the correct quadrants, because we have a coordinate in the fourth quadrant. So if you're using the two values, positive 25 square root of 2 and negative 25 square root of 2, just make sure that you have the positive ones with the angles that are already in the fourth quadrant, and the negative r values with the ones that are showing in the second quadrant. So here you can see them pairing up the values all together. You should have two of them that use negative 25 root 2 paired with 3 pi over 4 and 11 pi over 4, and two of them that have positive 25 square root of 2 paired with 7 pi over 4 and 15 pi over 4. So make sure you pair them according to the quadrant of the coordinate that you have. If they had given us an even bigger interval, like 0 to 6 pi, we would just keep adding pi to our answers. So then we would include the 19 pi over 4, and we would do it again and get 23 pi over 4. So just keep adding pi to your angles. Make sure you get a common denominator for computing those. And that's all for the notes. Thank you, guys.